We are now at the end of Chapter 1, Section 2, and the section right here, this problem is called Applying the Concepts. If we were in class together, I would ask you to be in groups of 4 and to talk to the people around you. And with us all mostly being at home, again, if you're watching this during the pandemic, then this is a great time for you to ask people in your house to come listen to you and talk to you. It's called discourse. And the more you talk out loud about what you're seeing and reading and sort through it in your brain, the more it's going to stick, the more it's going to make more sense, so that when we get to the next section and build on it, you've got a really good foundation from the start. The other thing that you can do is you have access to your fellow and classmates, where you can contact them. Y'all can set up any kind of form of social media where you can communicate back and forth and actually work through this problem together. So what I suggest is that you go ahead and hit pause and answer a couple of these by yourself, and then unpause, walk with me through a couple of these, and then pause again. In other words, not just being a sideline participant, actually being involved and digging down into what's going on, what you would have chosen, whether you chose it right or wrong, learning from that answer. Or maybe it was right but in a different way. So starting right here, it says let's name the variables under the study. So anytime you get ready to work on a problem, it's going to be good to read the following, look at everything going on in a chart. One part is labeled industry, the other is number of fatalities, and then you have some different modes of transportation: highway, railway, water, and aircraft, and then the number of fatalities. And then we can always go to where this came from, what year, etc. And you should always question, is this real data, made up data of what's going on? And so now we're going to put everything together that we were talking about in 1-2, and like here, name the variables under the study. Well, that goes all the way back up here. I won't turn to that one. And it's the things that can change. And so our variables are the industry, and the question is, which industry? Oh, well, let me pick highway. And the other variable is, then what are the number of fatalities for highway, that industry? So the two variables are industry and number of fatalities. The other thing I want to go ahead and point out is I won't do all of these throughout the book, and you feel free to do that. And I'll even point out at the bottom, page 38 has the answers. And so do these, use these, play around with these. Use them to your advantage as long as you're learning. Then categorize each variable as quantitative or qualitative. So let's start with industry. Looking at industry, is it a quantity or is it a quality? And I won't turn back on that one either. So looking at industry, is it a quantity or quality? Well, it's a quality. It's a type of an industry. So the first variable, industry, is qualitative. But then when we look at number of fatalities, it is a quantity. So there we've categorized them. Number 3, by the way, you might want to hit pause again, answer 3 and 4, and then come back together. Number 3, categorize each quantitative variable as discrete or continuous, the quantity ones. Well, we call this one qualitative. We call this one quantitative. And so looking here, we're going to categorize whether it's discrete or whether it's continuous. So if they're wanting to know if it's discrete or continuous, and it's our number of fatalities, I do want to go ahead and flip back. And I want to look here where it says discrete, continuous. And I need to scoot that up. So discrete, it's not infinite, no fractions, no decimals. And we are talking about fatalities. We're talking about death. And on continuous, it is infinite. In other words, in between. We're not going to have any partial deaths. And so with that in mind, is it continuous or discrete? Well, it's going to be right here. Categorize, it's going to be that our quantitative variable is discrete. Identify the level of measurement for each variable. Level of measurement. That was part of the video that I said you really need to grab some index cards or something, and we're talking nominal, ordinal, interval, or ratio. So let's start with the first one. Let's start with industry. An industry. These look like buckets. You're either in highway, railway, water, or aircraft. And so if you're looking at these, the one that turns out to be buckets will be this one. An example is like zip code, and then even up here like gender, eye color. These are just buckets, nothing measuring and saying one's better than the other. So the level of level of measurement, industry, is going to be nominal. Now let's look at the number of fatalities. And the number of fatalities we get here, like, can it be ranked, but it's not precise. Interval, it does have a meaning in its interval value, but there's no meaningful zero. And then ratio, there's a meaningful zero, a true zero. And that's what we have here. Zero is meaningful. How many fatalities? 0. So this one is going to be ratio, because there is a meaningful or a true 0. The railroad has the fewest fatalities for the specific year. Does that mean that the railroads have fewer accidents than the other industries? And what you'll hear throughout our semester is in statistics, you really need to be kind of like a reporter, just the facts. You're not embellishing, you're not giving opinion, it's just a fact, just the facts. But you don't lose your brain, and you do get to have some comments. And so there will be places that you're asked to give comments. And so with the railroad having the fewest fatalities, does it mean it's the safest, that it only had 44? And this is talking about modes of transportation. And so does it mean that they have fewer accidents than the other industries? And this might be a really good place to mention, well, most people don't ride railroads. But then you would need to back that up with some data, because we have Amtrak. But are there as many people riding Amtrak as there are vehicles? Yes, no, maybe. So it is good in this class that you get to make your own comments, but you got to practice that. You got to practice coming up with your own thoughts and opinions, because sometimes in math you're told to think this and do this and regurgitate this. And so that's pretty cool about this class. Part number 6. What factors other than safety influence a person's choice of transportation? Yet another example of what could be, and this is opinion or comment. You can't say, well, because the dumb whatever. No, you can't say that. But you can say words like it seems like, it could be, possibly. So possibly could be. Other factors, think about what you would choose and what you would think. Money, convenience, the schedule, what are you trying to do, your goals, is it a vacation, is it for business? So what other things could you write down? And do practice writing short sentences. From the information given, comment on the relationship. And I went ahead and jotted down a couple of other things, because this is where I feel like students have the most trouble, is that what do I say? Well, it's good to have a pattern. A good pattern is, and I wrote the word compare, a good pattern is to say the lowest one. Railway accidents have the least number of fatalities. There's you a sentence. Highway accidents have the most number of fatalities at 968. You can restate these numbers, use these words over here. You can use words like the industry of highway accidents. I don't like that one, but highway accidents have a total of, and then it doesn't tell us the year, and we could add more in there if we knew the year or more of the details of what was going on in the Bureau of Labor Statistics. But we could even say that. The Bureau of Labor Statistics reports that. Then you can also compare this way. You can do highest and lowest. You can compare this way. You can rank them and say, railway accidents have the least amount of fatalities. Next, water vehicle accidents have 52, which is just slightly higher. Slightly, possibly, kind of. And then you can jump to the next one, aircraft, and then you can start playing with numbers like 50 times 50, not times, sorry, 50 plus 50 plus 50, so 3 of these get 1 of these. So you could even say something like aircraft accidents are 151, which are 3 times more than water vehicle accidents. And so I just wrote some notes like compare. You can put them in order, like one's greater than the other one, one's less than the other one. Order, you can go ahead and say from least to greatest. The times numbers, those are always good to look for, like 3 times as much, 2 times as much, 10 times as much. And then fact. You can throw in some kind of fact if you have some, and it is always good to back it up with a source. And a fact or a thought could be that there are many, 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 many more people in cars than there are on the railway, in boats, or in aircraft. But be careful when you throw out some kind of comment like that to be able to back it up with data.